Okay, welcome back, everyone. So before I show what address is associated to what variable, let's go ahead and do a couple lines here, just show you another way to do a short int. You simply can write short, and it will have the same effect as a short int. So we will compare num7 to num4. Another one, however, remember when we did long int for num5, right? We want to see what long int, what effect does it have in terms of reserving the amount of bytes to store something like num8. All right, so let's compile and run this. Okay, and you can see now that simply short is 2 bytes. Long int now takes up 8 bytes. So this is ideal for whole numbers, large whole numbers. Okay, so if you want to do something like that, then you would go with long int. Okay, now remember, all of these bytes reserved for your variables are tightly coupled to the platform you're using, the hardware you're using, and the operating system that you're using. Okay, typically your operating system and hardware work together in terms of reserving space and what's allowable by the language here. Okay, so keep that in mind. If you're on older computers, older platforms, a short might be just 1 byte. So, so keep that in mind again. All right, so now let's go ahead and jump into what are the memory addresses assigned for these variables. And for that, we're just going to keep, track a few of them. We don't have to track all of them. So I'm going to do another print statement here. And we're going to show the memory addresses associated with some of our variables. So when you declare a variable, you are assigning an address for it and a number of bytes from that point. Now, typically on computers, each byte has an address. So if you're reserving 4 bytes for something, typically when you get back an address of that something, it's only the starting lowest address of that something. Well, let's look at it. Let's say or the highest, depending on which direction the memory is read. Let's go ahead and print where num1 is. So num1 is stored at this location. And that would be a %d. And the reason is an address will be an integer. Okay? It will be a whole number. And here's how you refer to an address. You're going to use the and % num1. So that is the reference or the location where num1 is in memory. Let me just put a few /n's in front of this to give me a nice little gap here before this line appears. So notice here my /n here for formatting. You could do them at the beginning. You could do them at the end. So this here gives me at least a couple lines so I can separate it from this output that we had here. Okay. All right. So let's compile and run. And there you have it. So it's going to be the last lines here at the bottom. So num1 is stored at this location, 2293572. So this is the address where that particular variable is stored at. Let's do the same for, let's say, num6, okay? And so we're going to go over here. Let me just close that. We're going to do printf. And we're going to do num6 is stored at this address. %d. So saying at this location or at this address, it means the same thing. And that would be and num6. So notice the syntax, the and % again, to delineate or to specifically say that's what we want. We want the address for num6. And there you have it. So num6 is at this address, 2293560. Okay? Now, are you guaranteed this address every time you run the program? No. Okay? This is in RAM, in random access memory. So when you rerun your program, you're going to be in a different stack. And again, I urge you to go and review how memory is managed while you're running a C program. And so you're not guaranteed these addresses every time you run the program. Okay? Especially if you have other processes running, other programs running. So memory is going to be in contention in terms of utilization by other programs. And you're not always guaranteed these. So don't use memory locations as fixed spots for referencing persistent data. If you want persistent data, you don't store it necessarily just in RAM. You use RAM for processing, for temporary storage, but you're going to store stuff in files. Right? So let's say you're collecting temperature for 7 days, but you want to rerun this program some other time. Well, you're going to have to shut down this program. You can't come back and turn the computer back on, and you will find your numbers back from memory. So they have to be stored in a persistent storage mechanism, such as your hard drive, and in particular, via a file. So you will have to create a file. Again, don't forget to review how file IOs are done in case you want to have persistent data. So any memory locations allocated to your variables are simply temporary while your program is running. Okay? And we could utilize those memories while the program is running to reference to these variables and do a whole bunch of things with them. That's where we'll introduce the concept of pointers throughout this course, which we will use in C and C++. Okay, so I hope you learn a lot. Our next lesson will be about pointers.